going back to grade 10, okay? Lewis dot diagram. For you to fully understand how to use the Lewis dot diagram, you need to think about this. There's group 1, group 2, group 3, group 4, up until you get to group 8, right? And at the same time, I know that when I talk about valence electrons that are found on the outermost energy level, right? Valence electron, not valency, but valence electrons. They determine the group. Meaning, if I'm in group 1, the valence electrons for group 1 is 1. If I'm in group 2, the valence number will be 2 up until you get to group 8. Okay? So when we draw the Lewis diagram, we need to pay attention to two things: valence and valency. So valence determines the group number. Valency tells me how many electrons are not paired for that particular element. Say for instance, in group 1 I have +1. That means I'm able to transfer 1 electron. Group 2, there's +2. I'm able to transfer 2 electrons. Group 3, +3, I'm able to transfer 3 electrons. Group 4, on the other hand, does not have a specific charge, okay? Does not have a specific charge because it's able to bond with all its 4 electrons that are surrounding that particular element. Okay, for instance, when I talk about carbon is able to bond with all its 4 electrons that are surrounding it. Okay, then group 5 has a valency of -3. Okay, meaning there's 3 electrons that are not paired. Group 6 has a valency of -2. That means there's 2 electrons that are not paired. And then group 7 has a valency of -1, meaning there's 1 electron that is not paired. Group 8 has no valency, simply because why? It's balanced. I want you guys to remember that. Right, now as you get to grade 12, you then realize that we categorize now these types of forces. In this case, we would talk about the van der Waals forces. Now, the van der Waals forces are divided into 2. We have the weak van der Waals forces, we have the strong van der Waals forces. When I talk about weak van der Waals forces, I am talking about the induced dipole forces, okay? Because you need to remember the conditions for the induced dipole forces. They are temporary forces, they are not permanent, okay? So the name for this particular weak van der Waals force we refer to as London dispersion forces, okay? And then as you move to strong van der Waals forces, you then realize that we have a dipole-dipole. Now remember the condition for dipole-dipole. We must have substances that are originally permanent what? Permanent dipoles, meaning they have positive and a negative side around a particular structure, okay? And then we also have then the hydrogen bonds as a result of the hydroxide or the hydroxyl group that is attached to this particular structure. Okay, now guys, it's very important that you know this. Okay, when you are looking for the type of bond, you must first calculate the electronegativity. I'm talking to the grade 12, the grade 11s and the grade 12s, okay? When you are looking for the type of the bond, you calculate the electronegativity. If the electronegativity is 0, for instance, then I know that the type of bond will be non-polar covalent bond. If the electronegativity is from 0.1 to 0.9, I know that I have a weak polar covalent bond. If the electronegativity is from 1 up until 2, for instance, then we get a strong polar covalent bond, but any number that exceeds 2 then becomes ionic, okay? In fact, if I put it correctly, it has to be between 1 and 1.9, and then from 2 then we have an ionic bond, okay? So that those ranges that I just gave you now, they determine the type of bond. But for you to be able to figure out the molecule itself, because remember, just because I have a polar bond does not necessarily mean that the molecule is going to be polar. No, it's not always the case. For you to be able to figure out what's going on with a substance, né? You calculate the electronegativity, it tells you about the type of bond, and then around the molecule, you need to check for lone pairs, right? And you also look at the site where the electrons are balanced. If there's even distribution of electrons, there's equal sharing of electrons, and the molecule is surrounded by negatives or surrounded by the positive, then that particular substance is going to be non-polar, okay? But if there's uneven distribution of electrons and there's unequal distribution of electrons or sharing of electrons, and around the molecule there's one site where we say it's electron poor, meaning there's less number of electrons. On the other side there's more number of electrons. Then that particular structure is one side where there's poor number of electrons, we say it's slightly negative, and then on the slightly positive, sorry, and then on the other side it's going to be slightly negative. Why? Because it's surrounded by a large number of electrons. One side has to be electron poor and one side has to be electron rich. The side that is electron poor talks to slightly positive. If it's electron rich, slightly negative. That's how we get a dipole. Right. Thank you very much, ladies and gentlemen. I hope that this has helped a lot into clarifying some of the misconceptions that we get. Please subscribe, and I will deliver more content and more theory as you request. Thank you.